Alright, let's solve this polynomial equation. 3x cubed plus 2x squared minus 8x plus 3 is equal to 0. In order to solve for this, the first thing we need to do is we need to factor the expression here. And let's call this polynomial expression f of x. So in order to factor this, this is a cubic polynomial expression. Let's use the integral zero theorem. So using the integral zero theorem, we want to postulate potential factors, right? So if we're looking at potential factors that we need to test out using remainder theorem and thereby factor theorem, the potential factors are going to basically be the factors plus minus of the constant divided by plus minus the factors of the leading coefficient. Okay, so factors of constant over factors of leading coefficient. Now to do this, basically the constant here is basically the 3, right? So plus minus factors of 3 are 1 and 3. Leading coefficient is also 3, so plus minus 1 and 3. So what we can test out is plus minus 1, 1/3, 3, right? So you're just dividing it by each number, right? So let's test out 1. 1 is always a safe bet. I'm going to do f of 1. So f of 1 is 3 times 1 cubed plus 2 times 1 squared. So once again, this is guess and check. For the most part, I would always test out 1 if it is a factor. And this actually works. So f of 1 is equal to 0, right? So because f of 1 is equal to 0, the remainder is 0. According to factor theorem, x minus 1 is a factor. So if x minus 1 is a factor, we can figure out the remaining factors by using synthetic division or long division, okay? So because the divisor here is linear, what I'm going to do is I'm going to use synthetic division just because it's faster, right? So this is x cubed, x squared, x to the power 1, x to the power 0, right? Maybe we should make some space there. Sorry about that. Okay, so this is x cubed, x squared, x to the power 1, x to the power 0. And you literally have to put some coefficients here. I just use the terms up top just for bookkeeping purposes. You have a 3 here, you have a 2, you have a -8, you have a +3. And your factor here is the 1. Right, so I'm going to bring this guy down. This is my leading coefficient. I multiply it. 1 times 3, +3. So then you add these coefficients, so you get 5. 1 times 5 is +5. -8 plus 5 is -3. And 1 times -3 is -3. And then when you add it, 0. The quotient here is basically going to be in the format of x squared, x to the power 1, x to the power 0, and this is your remainder, right? So your quotient is going to look like 3x squared plus 5x minus 3, okay? And in factored form, that's going to be times x minus 1, okay? So this is basically you factor. You can factor this guy further, right? So if I wanted to factor this guy further, right, you want two numbers that multiply to -9 that add up to +5. Well, there aren't any two numbers that do that. You can't really factor this. So we can just kind of stop at this point, right? X minus 1, this is equal to 0. Now you could solve this using quadratic equation. Let's see if there are solutions. So I'm going to use the discriminant method, right? b squared minus 4ac. As long as it's not equal to 0, then there are solutions present. Right, solutions would be possible. Right, so in this case, b squared, this is your a value, this is your b value, this whole thing is your c value, right? So if we test it, you get 5 squared minus 4 times 3 times -3, which is 25, plus, it looks like 36 is 41. So there should be two solutions. So you can actually figure out those two solutions using the quadratic formula. So if you let 3x squared plus 5x minus 3 equals 0, right, then x is equal to -b plus minus b squared minus 4ac over 2a, right? So this is going to be somewhat of irrational numbers, right? So we figured out what the b squared minus 4ac term is. It's 41. So the -b here is -5 plus minus square root 41 over 2 times a, which is 2 times 3, which is 6. So your answer, so x can be possibly -5 plus minus square root 41 over 6. So that's one of our solutions. The other solution here is x can be equal to 1. Okay, so therefore, right, x can be equal to -5 plus minus 41 over 6, or x is equal to 1. Okay, so that is our solutions for our function. So that's how we can solve our function, right? So first you would factor this, and then you can just equate each factor to 0 and solve.